Question 4, proof by induction. F of k is 13 to the k minus 6 to the k. And if we check out n is 1, we get 13 minus 6, which is 7, which clearly is divisible by 7. The standard procedure with divisibility is to consider f of k plus 1 minus f of k, which is 13 to the k plus 1 minus 6 to the k plus 1, take away 13 to the k minus 6 to the k. But a bit of subtraction should give us 13 times 13 to the k minus 6 times 6 to the k, take away 13 to the k minus 6 to the k, and that in turn is 12 times 13 to the k minus 5 times 6 to the k. Now, sometimes at this point we get something which is obviously divisible by 7, but that's not the case here. You'll notice 12 and 5 differ by 7, and that means we can separate it out into 7 times 13 to the k plus 5 times 13 to the k minus 5 times 6 to the k. And that's the same as 7 times 13 to the k plus 5 times f of k. But if f of k plus 1 minus f of k is equal to that, then it follows that f of k plus 1 plus 6 f of k is equal to 7 times 13 to the k, and we want to know what f of k plus 1 is, so it's 7 times 13 to the k minus 6 f of k. But 7 times 13 to the k is divisible by 7 by inspection, and 6 times f of k is divisible by 7 by the inductive hypothesis. That is assuming we've assumed true for k, n equals k. So it's true for n equals k plus 1, and therefore true for all n belonging to the natural numbers by the principle of mathematical induction.